Hello, and welcome to this video on integration of rational functions. A rational function is a function that comes from dividing two polynomials. In this case, we have a quadratic divided by a cubic polynomial. And when we have a rational function, like this one, we use something called partial fractions to rewrite the integral in terms of easier integrals. So let's see how we can rewrite the integrand, the function we're integrating, in terms of easier functions that are nicer to deal with. To decompose our function into nicer functions, we're going to decompose 2x cubed plus 3x squared minus 2x into factors. We're going to factor out the denominator. And to factor out the denominator, we can start by noticing that x is a common factor. So we have x times 2x cubed minus 1, so that's 2x squared, plus 3x squared minus 1, so that's 3x, and then minus 2. And then to factor the quadratic, we can use various tools. One option is to use the fact that we can factor out a quadratic this way. We write the coefficient of x squared times x in two separate brackets, and then we divide by the coefficient of x squared, and then we find two numbers that multiply to the multiplication of the product of 2 by -2, so that's -4, and the addition of those numbers is going to be +3. And we find that those numbers are +4 and -1. Here we have +4 and -1. So our polynomial from the integrand, the denominator, can be seen as x times 2x plus 4 divided by 2 gives us x plus 2, then times 2x minus 1. Okay. Once we find a decomposition of the denominator, then we see what happens with factors. We see three factors here that are distinct factors. There is no repetition. Because there is no repetition, what we can say is that the fraction we were given can be written in terms of three fractions, one per factor. We're looking at a constant to be determined divided by x, plus a constant to be determined divided by x plus 2, and then plus a constant divided by 2x minus 1. So the function we're integrating can be written in terms of 1 over x plus 2, and 1 over 2x minus 1. We need to find a, b, and c. We're going to find those constants in a moment. But then what we will be able to say from this decomposition is that the integral of x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x is the same as the integral of those three terms added up. And integrals are linear. The integral of an addition is the addition of integrals, and we can pull constants out. So we get a times the integral of 1 over x plus b times the integral of 1 over x plus 2 dx, and then plus c times the integral of 1 over 2x minus 1 dx. And those integrals are a lot easier to find than the integral of the thing we started with, as the integral of 1 over x is the ln of the absolute value of x, the integral of 1 over x plus 2 is the ln of the absolute value of x plus 2. And then the integral of 1 over 2x minus 1 is a half of the ln of 2x plus minus 1 in absolute value. And then plus a constant that is an integration constant, let's call it k. Okay. So once we find our constants a, b, and c, we will know the integral of this function. Now let's find the constants on the next page. And then we come back to the expression that is the integral of the rational function x squared plus 2x minus 1 divided by 2x cubed plus 3x squared minus 2x. Okay. Now to find a, b, and c, we impose that we need x squared plus 2x minus 1 over 2x cubed plus 3x squared minus 2x to be equal to the addition of those three terms that we saw before. A over x, b over x plus 2, and c over 2x minus 1. But when we add those terms on the right-hand side, we find that we look for a common factor, which is the product of all those three things, and that's how we get 2x cubed plus 3x squared minus 2x. And then on top we have a times x plus 2 times 2x minus 1, and then plus b times x times 2x minus 1, and then plus c times x plus 2. When we add fractions, we'll look for a common denominator. And the common denominator in this case comes from multiplying all the terms because they have nothing in common. But when we multiply those three terms, we get our cubic polynomial. We decomposed our cubic polynomial into x times x plus 2 times 2x minus 1. So we're asking for x squared plus 2x minus 1 over the cubic polynomial to be equal to this whole expression right here divided by the same cubic polynomial. Then we need x squared plus 2x minus 1 to be equal to a times x plus 2 times 2x minus 1 plus b times x times 2x minus 1 plus c times x plus 2. And that equality should be true for all values of x. And we're supposed to find a, b, and c, so that the equality holds for all values of x. But there is a trick to find a, b, and c by giving x certain values. We want to take values of x that make one of those factors, x or x plus 2 or 2x minus 1, equal to 0. And you will see why we want to do that. So x plus 2 equals 0 when x equals negative 2. And when x equals negative 2, on the left-hand side of the equation we just wrote, I'm going to highlight it, we get that minus 2 squared plus 2 times negative 2 minus 1 should be equal to a times, and minus 2 plus 2 is 0. So this term goes away because we have a 0 as a factor. And then we have b times negative 2 times twice negative 2 minus 1. And then we have a plus c times -2 times 0, because when we substitute -2 into x times x plus 2, we get a 0. We're saying that twice -2 squared, that's 4. And then -4 minus 1 should be equal to b times -2 times -5. So -1 should be equal to b times 10, or 10b. And from there we find that b equals -1/10. So by giving x the value -2, we found that b equals -1/10. We chose x equals -2 because then the right-hand side of the equation that is highlighted gets really easy when x equals -2. Same with x equals 1/2, because in that case, twice x minus 1 is 0. So we get that 1/2 squared plus twice 1/2 minus 1 should be equal to a times 1/2 plus 2 times 0. So we don't even bother to write anything with a, because it's going to be a times 0. And then plus b times 1/2 times 0. The only term that will survive is c times 1/2 times 1/2 plus 2. So 1/4 plus 1 minus 1 should be equal to c times 1/2 times 5/2. Or we're saying the same as 1/4 should be equal to 1/2 times 5/2. That's 5/4 of c. So c is 1/5. So the quarter cancels out. We have both sides multiplied by 4. We get 1 equals 5c. And then we divide both sides by 5 to get c equals 1/5. And finally, when x equals 0, we get that the left-hand side, so 0 squared plus twice 0 minus 1, should be equal to a times 0 plus 2 times twice 0 minus 1. And all the other terms cancel out. Well, not really cancel out, they go away because x equals 0. So we have b times 0, then c times 0. So -1 should be equal to twice a times -1, so -2a. And from there we get that a equals 1/2. Okay. So back to the equation we wrote here. We have, let's just take it to the next page. We have that a equals 1/2, b is -1/10, and c is 1/5. So this is equal to 1/2 of the ln of absolute value of x, then minus 1/10 of the ln of x plus 2, and then 1/5 multiplied by 1/2, or 1/5 divided by 2, that's the same thing, that's 1/10 of the ln of 2x minus 1 plus a constant, that is the integration constant, and then we can take those powers to the inside of ln. We have the square root of the absolute value of x We have minus the ln of, in this case, the 10th root of the absolute value of x plus 2, and then the ln of the 10th root of the absolute value of 2x minus 1, then plus k. We can use properties of logarithms to say that the ln of this minus the ln of that plus the ln of that is the ln of the absolute value of x under the root times the absolute value of 2x minus 1 under the 10th root, and then divided by the 10th root of x plus 2 in absolute value. And then we have the constant k totally separate. And this is the answer. Or you can leave it at what we had before. That's another possibility. You just match your answer with options that are provided, if any. Or and you might have to use the properties of logarithms, or just leave it at whatever whatever point you feel that you're done with the problem. And we're done with the problem when we see no integrals to be found, and when we find a, b, c, and any other constant and substitute the value into the expressions. All right, so that was it. And if you have questions, let me know. I'll be happy to help. Bye bye.